A second object just appeared near 3I Atlas. Both are unnaturally bright. Both have no tails. And NASA won't release the Mars images. Astronomers just confirmed the Comet C 2025 V1, also called Borisov, drifting near the interstellar comet 3I Atlas. Both are visible right now. Both violate standard comet physics. They're bright and active, yet completely tailless. That shouldn't be possible, and the Escort object theory is now impossible to ignore. Borisov's legacy, a comet that changes everything. This wasn't a random sky survey discovery. On November 2nd, 2025, at the Margot Observatory in Crimea, astronomer Gennady Borisov noticed something moving strangely. Not like ordinary asteroids in the solar system, it was completely off the expected trajectory. He measured its brightness at approximately magnitude 12.1 and saw a faint, hazy cloud surrounding it, called a coma, about 30 arcseconds across. That alone made it extraordinary. Within hours, he reported it to the Central Bureau for Astronomical Telegrams, attaching precise coordinates and early photometric observations. The object was immediately flagged with a provisional code that told the global astronomical network, "This is not standard. And this isn't just any observer." The name Borisov carries serious weight in comet science, since he discovered the first confirmed interstellar comet in 2019. So when the same astronomer, known for his careful study of unusual interstellar objects, reports another outlier 6 years later, the entire scientific community pays attention. Within 24 hours, observatories across 4 continents confirmed something physics can't explain. A comet that's bright, active, yet has no tail. Global Scramble, the tailless comet mystery. The moment the alert went out, the reaction was immediate. Observatories from Russia to Japan, Ukraine to the Canary Islands all turned their telescopes toward the new object. Digital images, brightness estimates, and position measurements began pouring in, almost in real time. Across every site, astronomers saw the same strange behavior: a bright, condensed coma, no visible tail, and a brightness that climbed faster than expected. By November 3rd and 4th, stations in Sukagawa, Lviv, La Palma, and across Russia all confirmed the same pattern. The coma had expanded to around 4.6 arc-minutes across, with brightness ranging from 10.9 to 12 magnitude, and still no reliable sign of a tail. Many reports described the coma as a perfect, glowing sphere. Within 1 week, the discovery had been independently confirmed from virtually across the globe. Amateur and professional observers traded data nightly, creating a live, worldwide record of the comet's evolution. And that's where the first true anomaly appeared. A comet that brightened rapidly, behaved the same across multiple observatories, yet stubbornly refused to grow a classic dust tail. 3 comets, 1 illusion, the geometry problem. By November 7th, 2025, 3 comets were threading separate paths through the inner solar system. C 2025 by 1 Borisov, Interstellar 3, I Atlas, and C 2025 K1 Atlas. From Earth's perspective, V1 and 3I appear near each other in the constellation Virgo, almost like companions traveling together. That visual proximity is what fuels the Escort object speculation, but appearances can be deceiving. When astronomers examined the true 3-dimensional positions, the illusion quickly fell apart. Orbital models show C 2025 V-1 roughly 0.55 astronomical units from Earth, crossing upward from below the ecliptic and only appearing near 3I Atlas on the sky because of our specific viewing angle. 3I Atlas is on a hyperbolic escape trajectory, staying outside Mars's orbit and reaching a physical distance of approximately 1.8 astronomical units from Earth at closest approach. On November 7th, the actual angular separation between the 2 comets is 44 to 51 degrees, depending on the observer's location, about the width of 2 outstretched hands at arm's length. That is nowhere close to flying in formation. Meanwhile, C 2025 K1 Atlas follows a completely different path, with a steep orbital inclination and a position in Leo that keeps it well separated from the other 2 both in angle and in physical space. The brief alignment window from November 6th through 8th, when all three comets are visible before dawn, exists only on a flat sky map from Earth's point of view, not as a tight physical cluster in actual space. So where does the Escort object narrative originate? It doesn't come from geometry. The apparent pairings are visual illusions, not evidence of real proximity. But when you combine that apparent closeness with unusual brightness behavior and a conspicuous lack of high-resolution space-based imagery, the gap between what we observe and what we understand gets filled by speculation. Here's what makes this even stranger. From Mars, these objects should be perfectly visible. So why hasn't NASA released a single clear image? How you'd see them in the sky and why that matters. In early November, the constellation Virgo dominates the southeastern pre-dawn sky, and that's where most of the observable action occurs. See 2025 V-1, Borisov rises first, approximately 2 hours before sunrise, near the celestial equator. That positioning makes it accessible from both hemispheres. Just a few degrees to the west, 3I Atlas moves along a similar track through Virgo. It appears slightly brighter, hovering around magnitude 10, but equally stubbornly tailless, even with increased solar activity occurring in the background. Further east, in Leo, C 2025 K1 Atlas stands apart with a faint golden yellow tail that shows up well in long exposure photographs. For dedicated observers, the short window from November 6th through 8th represents a rare observational challenge. 3 comets with 3 different orbits and brightness profiles, but one fundamental question: why are 2 of them bright and active yet so nearly tail-free? This moment serves as a crucial baseline. We know how they look now, how bright they are, and where they sit in the sky. Any deviation from this baseline in the coming weeks becomes immediately significant. The physics problem: bright, tailless, and too stable. From a physics standpoint, these comets are behaving just strangely enough to constitute a genuine problem. Under normal conditions, as a comet approaches the sun, ices sublimate, dust is released, and radiation pressure pushes the smaller grains away to form a visible tail. In the case of V1 Borisov and 3I Atlas, the data suggests a completely different regime. Their comae appear dominated by larger, heavier dust grains that resist the normal tail-forming process. In early November, both comets sit at high phase angles. The Sun, Comet, and Earth are arranged such that forward scattering of light makes the coma appear brighter from our perspective. That same geometry can drown out any faint tail and glare, leaving observers with bright, dense comets that look more like glowing spheres than classic streaking comets. On top of that comes the brightness anomaly. Photometric data place 3I Atlas around magnitude 9.8, when standard light curve models suggest it should be closer to 11.2. That 1.4 magnitude difference translates to nearly 4 times the expected brightness. Astronomers at JPL and ESA have updated their orbital solutions to check for non-gravitational accelerations, forces that would indicate outgassing or something more unusual. So far, the non-gravitational term for 3I Atlas is small, near the threshold of statistical significance, and not clearly indicative of anything exotic. The bottom line: the comet is brighter than predicted, its tail structure is weak or missing, and any orbital deviations are marginal. None of that proves an escort exists. It does, however, describe a cluster of genuine anomalies that demand more and better data, especially from vantage points other than Earth. That's where Mars, and NASA's assets there, should come into play. Mars has the perfect angle, so where are the images? Mars is in an ideal position to provide us a different observational angle on C 2025 V1 and its surroundings. That's precisely why the lack of clear imagery from Mars-based spacecraft is becoming such a significant point of tension. China's Tianwen probe, currently in orbit around Mars, quietly released its first observation of C 2025 V1 in early November. It confirmed a bright coma, but provided no detailed view of the nucleus, and no obvious tail structure. Attention then shifted to NASA's Mars Reconnaissance Orbiter and its HiRISE camera, one of the most powerful imaging systems ever sent to another planet. Multiple target of opportunity proposals have been submitted to use Hubble and the James Webb Space Telescope to study these comets in detail. None have yet been approved or scheduled, and no new space-based images have entered the public domain. The silence is conspicuous, and here's what makes the data blackout even more suspicious. These comets just survived massive solar storms without reacting. That shouldn't be possible. Solar storms, no reaction, and the Escort theory. Recently, solar storms swept across the inner solar system. Geomagnetic indices spiked dramatically, and auroras were reported from North America to Siberia. For comets, this level of space weather usually represents an opportunity for dramatic visible behavior. Stronger solar wind and increased ultraviolet radiation typically trigger outbursts, fresh dust release, and more prominent tail development. But for C 2025 V1 Borisov and 3I ATLAS, observers have so far reported no major changes whatsoever. There's no sudden new tail, no sharp reconfiguration of the coma, and no clear response to the heightened solar environment. That lack of reaction is another significant oddity, still technically within the bounds of natural behavior, but not what experienced comet observers would have expected. In parallel, speculation has intensified about a dispatch from 3I ATLAS. The idea that something smaller, stranger, or even artificial might be traveling with it. The crucial status update is that none of these signatures have been definitively observed so far. Right now, the orbit and coma of C 2025 V1 appear stable. There's no confirmed escort, no confirmed dispatch, only a growing list of warning signs that astronomers are actively watching for as new data arrives. December 19th, watch list. Evidence-based warning, not panic. Between now and December 19th, both professional astronomers and serious amateurs should treat this period as a critical watch window, especially if the slow trickle of Mars-based or space-based imagery continues. The coming weeks represent a chance to compare predictions with reality and see whether the behavior of C 2025 V1 or 3 I ATLAS remains stable or begins drifting into territory that standard comet physics cannot comfortably explain. Trajectory is the first thing to monitor. Any update from JPL, ESA, or major ephemeris tools showing unexpected motion, outside normal error bars and not explained by outgassing, deserves immediate close attention. Brightness is the second. Comets should brighten and fade in predictable ways that track their distance from the sun and their activity level. Deviations from predicted light curves, especially synchronized deviations between multiple objects, would be significant. Fragmentation is the third. Comets can and do break apart, but their fragments usually move in patterns that match our models of rotational stress and gravitational forces. Any fragmentation that doesn't follow these patterns warrants investigation. Coordinated behavior between V1 and 3 would be another major red flag. These objects are not physically close and should not influence each other gravitationally, so any synchronized change in brightness, direction, or coma structure would raise extremely difficult questions. Signals also matter. Natural comets can produce radio signatures from their ionized gas, but anything unusually structured or outside known emission patterns coming from their region would move this story into a fundamentally different category. Finally, keep watching what does, or does not, come from Mars and from space telescopes. High-resolution images from Mars Reconnaissance Orbiter, Tianwen, Hubble, or JWST could either confirm a simple cometary explanation or reveal something far more complicated. If any of those platforms capture compact, sharply defined objects near the comets, or anything that looks non-diffuse and structurally organized, the tone of this discussion will shift immediately and dramatically. The warning is not that something is definitely artificial. The warning is simply this: do not let a data bottleneck decide the narrative for you. As solar storms continue and these comets evolve, every new image, every brightness curve, Every orbital update matters profoundly. The cosmos is presenting us with puzzles in real time. Whether this ends as a case study in unusual comet physics, or the first indication of something much stranger, will depend entirely on the quality, transparency, and speed of the data we receive between now and that December 19th checkpoint. Stay critical. Track the actual predictions against observations, and let the evidence, not the speculation, decide what you believe.